All right, so let's talk very briefly about biodigesters. Sometimes you'll hear this called an anaerobic or an aerobic digester. Sometimes it's called a biogas digester, and sometimes we hear the word bioreactor. So all of these words essentially mean very similar things. When we talk about biodigesters in wastewater treatment, we're specifically looking at anaerobic or aerobic bioreactors that are producing biogas in the system. So our biodigesters, the purpose of this is it's a type of secondary treatment. So we've been talking about activated sludge in class and about aerobic and anaerobic treatment. And basically what a digester is a tank system. It's a reactor style system where we have removal of organics and a decrease in BOD content as a result of either aerobic or anaerobic respiration. And so just like we've talked about with activated sludge, the purpose is really to break down those organic substrates. So it's a type of secondary treatment, and it's a little bit more simplified than the activated sludge processes that we've been talking about. So this is an example of a very specific type of biodigester, but I think it's a good overall photo to show you what's going on in the systems. So what you'll see here is this is a proprietary technology, so they're specifically looking at removing specific things, but the idea is that they are pushing in all of their wastewater, and their wastewater has high fatty acids content and what we call FOG, which is fat, oils, and greases. And so we're pushing that into the bottom of a chamber where we have a mixing blade, much like we would see in a flocculator or any other type of mixing chamber. And we have this mixing zone down at the bottom where things that are being pumped in mix with what's already in the tank. Above that we have what's called the sludge zone. And then kind of in this fluid in the center is kind of where reactions are occurring. So within the sludge, you're going to have anaerobic and aerobic microorganisms, and they're going to be performing not only aerobic and anaerobic respiration and producing CO2 gas, but many times we also have what's called methanogenic bacteria. And so one of their byproducts is methane. So CH4 is what kind of comes out in this biogas. And so the biogas is primarily methane when it comes out of the system, and that can be used for other types of energy production, which is very important. So overall, it's just a tank design like we've seen in the past, where you kind of have this sludge layer and a mixing layer where reactions are occurring, and we're just letting those reactions occur naturally at ideal temperatures and pHs that are important for these reactions. So basically what's happening in a biodigester from a biological standpoint is that we bring in what we call complex organic matter. So we bring in carbohydrates, proteins, and fats. So it's a lot of what's in fecal content. It comes out of your body, it comes out of the body of animals, and that complex organic matter gets changed into what we call soluble organic molecules by what we call hydrolysis. So breaking apart things using water. And that breaks down into smaller components that are a little bit easier for microorganisms to utilize. So we break it down into things like sugars, amino acids, and fatty acids. Then we have what's called fermentation. And fermentation is going to take those soluble organic materials and it's going to break them down into multiple different components. So we can break them down into what we call volatile fatty acids. We can break them down into acetic acid or hydrogen gas and carbon dioxide. So there's many different fermentation pathways. From there, when we have our volatile fatty acids, we can go through what we call acetogenesis, which is basically turning things into acetic acid and H2 and CO2. And then we can go through a final phase of methanogenesis, which basically means the creation of methane gas. So what's happening in a digester is that we're going from these complex organic materials, things that are in feces and urine, carbohydrates, proteins, fats, and we're breaking them down through multiple biokinetic pathways to get to methane and CO2, and that's what your biogas is at the end of the day. So this is just another schematic to kind of give you a sense of what that is, what that is in a broader sense. Many times this is used when we have agricultural waste or wasted foods and we have lots of biosolid content in our system, and we do some pre-processing, so we do some pre-treatment, get rid of some solids, and then the anaerobic digester, or it could be aerobic, is the main form of treatment. So for small systems, this is actually a really great technology to use. And then there's normally some post-processing that we have to do when we get solid products and liquid products out. But then we also get biogas, and we have to remove some impurities from it. But then that can be used for electricity, thermal, and fuel. So what's really cool about this technology is it can be employed at a large scale or a small scale. But if we use it as a small scale, many times we can actually get some products out of it that are very reusable and very renewable. And so many times it's looked at as a very sustainable technology as a result. So this is just another schematic to give you a sense of what that looks like. Organic waste comes in, we digest it in our biodigester, and then we have biogas, potentially for cooking, for biogas stations, heat, electricity. There are some really good examples of this technology being used in sustainable eco-lodges around the world. So these places where people go for holiday, to these hotels and these really nice, beautiful areas that are on their own wastewater systems, and they actually use biogas digesters to power all of their systems. And it's a very renewable style of technology. So key parameters that we need to know if we're going to dissolve a biodigester is we need to know our oxygen requirements. So do we need to have extra dissolved oxygen in the system? You're going to need to know your solids concentrations, your carbon concentrations, your BOD, and basically that's going to allow us to calculate mass loading rates into these systems. Those are really, really critical design components for biodigesters. Temperature gets really important as well. So we need to be optimized for the specific biochemical reactions that we want to have occur. Remember, we don't want to kill our organisms in these systems. Excuse me. And then what type of sludge is being added to the digester is actually very important as well. So we can have sludge or sediment coming out of a primary clarifier that we're treating. We can have agricultural sludge, we can have activated sludge, and all of these different types of sludges have different properties, and they're going to need a little bit of a different operation of the biodigester in order to adequately treat those types of sludges because they have different components in them. So biodigesters are a pretty simple technology, so there's only a few couple key calculations that you need to know. So things like digestion time, so how long does that sludge need to be in there, kind of like a mean cell residence time. Our organic solids loading rates, so how fast are we loading BOD and TOC into the system, and then your volume of your tank and your reactor. Very simple technology. And some key potential impacts are that we've talked about biogas as a product of these systems, and that's something that's actually very usable. So it's a source of energy to produce electricity. We can use it for thermal heating. And the other thing about this technology that I think is very interesting is that it can be applied at both a large and a small scale. So you can use this in a full-scale water treatment plant, or wastewater treatment plant. But it's actually a really great technology for small systems that might be off the grid. So people that don't have a lot of consistent power to their system. It's really great because they're actually producing electricity many times as a result of using this technology. It requires very little maintenance and operational oversight. So it's a technology that you can kind of, once it gets working, you can kind of leave it alone. There's some things that you have to watch out for, but for the most part, it's a very hands-off technology, and that's a very good benefit when it comes to small systems. So that's just a very brief overview of biodigesters. We'll talk a little bit about some of the things that we can calculate when we get to class.